gate signal or rectangular signal. This is another standard signal. Here the name is rectangular. The shape of the signal is rectangular shape. That's why the name is given here rectangular signal. The shape is like this. Negative time axis it is not defined. From this time onwards, this axis onwards, it has constant amplitude up to particular time period. Now the shape of the signal is rectangular shape here. So this function is defined in particular time period. In particular time period with constant amplitude. That constant amplitude is A. So gate function. These time limits are from minus t by 2 to plus t by 2. So rectangular function or gate function explains time is from minus t by 2 to plus t by 2. It has constant amplitude A, and remaining function, remaining time period, it is not defined. This signal is rectangular signal or gate signal. This representation is graphical representation. Now we require functional representation also. That functional representation is x of t is equal to a rect of t by capital T. So just now we discussed the sinusoidal signal. Sinusoidal signal standard equation is a sine of. That sine explains it's a sinusoidal signal. Similarly, here this RECT, rect explains this function is a rectangular function. So this rectangular function has particular amplitude. The amplitude is A. So within these limits minus t by 2 to plus t by 2, it has constant amplitude. The amplitude is A. So that is A here. And the function is rectangular function. So rect of. This t explains the time axis. So the function is changing with respect to time t by, this is capital T. Capital T explains the total time period of the signal. This total time period is here t here. Okay. This is another functional representation, A rect of t by capital T. This is functional name here. This function is also called as rectangular function. And the same function we can write like this. X of t is, this function has constant amplitude, A amplitude. This amplitude is defined from minus t by 2 to plus t by 2. So minus t by 2 less than or equal to t is less than or equal to t by 2. Within this time period it has constant amplitude. Other than this time period it should be 0. 0 elsewhere. This elsewhere explains the remaining conditions of this one. Other than these conditions. Within this time period it has constant amplitude, and this side it is 0 and this side it is also 0. That is explained by elsewhere. So x of t is equal to 0 elsewhere. This is another functional representation of rectangular function. Now I am taking one example. X of t is equal to 2 rect of t by capital 6 is there. Say 2 rect of t by capital T, this amplitude is 2, time period is 6. If it is defined here t, the time limits of the function is minus t by 2 to plus t by 2. Now, the time limits of this function is, with respect to time axis, minus 6 by 2. Minus 6 by 2 is minus 3, plus 6 by 2, that is plus 3. So within this time period, it has constant amplitude. Other than this is 0. This amplitude is 2 here. So x of t is equal to 2 rect of t by capital 6. So t by 6. So minus 3 to 3, the amplitude is 2. Other than this time period, this amplitude is 0. This is functional representation of this rectangular function. The rectangular function standard name is A rect of t by capital T. This is another standard signal. One more standard signal is there, signum function. Signum function or signum signal. This signal is defined positive time axis, positive amplitude, that should be 1. Negative time axis, negative amplitude, this should be -1. Exactly at t is equal to 0, this should be 0. T greater than the 0, this side, it has constant amplitude 1. T less than the 0, negative time axis, this is -1. This function is also called as signum function. And again, this function requires another standard representation. The representation is SGN of t. SGN, this explains the signum. Now, this is graphical representation. Then the functional representation is SGN of t is equal to 1, this side, t greater than the 0, this side -1, t less than the 0, exactly at t is equal to 0, 0. Signum function is not defined at origin. Greater than the 0, positive time axis, less than the 0, negative time axis, so -1 and +1. Exactly at time is equal to 0, this amplitude is 0. This function is a signum function. This is another standard signal. Then one more signal is there, sampling signal, or it is also called as sinc. Sampling signal or sinc function. This is another practical representation of the signal. This is defined from the sinusoidal signal. But in sinusoidal signal, amplitude is always constant. It gives the A and -A representation. But here, the amplitude of the sinusoidal signal is exponentially decreases. That representation is with respect to time axis. Sinusoidal signal amplitude is exponentially decreasing. It's like this. Sinusoidal signal amplitude, exactly at t is equal to 0, it has amplitude 1. If the time axis increases, amplitude of the sinusoidal signal is exponentially decaying. This type of signal is called sampling signal or sinc function. Then the functional representation of this is sinc of theta is sinc of theta, or this axis, time axis, write with t here. Sinc of t is equal to sin t by t, sin phi t by pi t. Sinc function explains sin pi t by pi t, because here t explains the time axis and this pi is a angle. Now let us take exactly t is equal to 0 here. At t is equal to 0, the function becomes like this, sinc of 0. Sinc of 0 is sin 0 by 0. Sin 0 by 0 is 0 by 0 here. 0 by 0 is not defined. That's why, according to the mathematical analysis, limit extends to 0, sin x by x should be 1. From this, limit t tends to 0 here. X is nothing but t tends to 0. Sinc of 0 should be always 1. This representation is not used in mathematical representation. That's why we have to write directly this should be 1 from mathematical equation, this equation. Limit x tends to 0, sin x by x is equal to 1. This is another standard signal sampling function or sinc function. One is a rectangular. The shape of the signal is rectangular shape, and here signum function. Positive time axis, positive amplitude. Negative time axis, negative amplitude. And one more is a sampling function. Sinusoidally amplitude is decreases. These three also comes under standard signals.